So as you complete the problems here in section 9C, this is dealing with exponential modeling. You either have a growth or decay. Growth is when r is greater than or 0. R is the rate, which is the percentage in these type problems. R is greater than 0 for growth. R is less than 0 for decay. If r is greater than 0, I'm taking 1 plus the rate. If r is less than 0, I'm taking 1 minus the rate. So if I have a decay type problem, I'm subtracting from 1. If I have a growth, I'm adding to 1. So our formula is the value we're trying to find, the initial value times parentheses 1 plus r, the rate, times 1 plus r raised to the t power. So in our problem, it says the population of town with initial population of 43,000 grows. So this is a growth. So I'm going to add 1 to this as a decimal. So it'll be 1 plus, move this 2 places to the left, 0.065. So it's 1.065 for the parentheses. Then the initial amount goes first, so 43,000 will go first. And we have our model for this problem, an exponential model. So our exponential model, the initial amount times 1 plus the rate, 0.065 is the rate, 1 plus 0.065 gives you 1.065 raised to the t power. So now you're going to have to use your graphing calculator. So using your graphing calculator, let me get the right calculator pulled up here. I'm going to have to reload mine. You won't have to go through this, so I apologize for that. This will just take a second. There we go, back up again, so we're good to go. So let me get to the menu I need to see. Get out of here, okay. So there's our graphing calculator. We have our model right here. So here's how you enter your model. Hit the y equals, and add something in there, so I'm just going to hit clear. I'm going to type this in exactly the way it's written. I'm going to type in 43,000, parentheses, 1.065, 1.065, parentheses, raised to the x power, because I can't put a t in there, I'm going to have to use x. Y is the q, and x is the t. Same thing. All right. Hit enter, that goes just to my next line. So I can get these values pretty quickly. I don't have to plug any numbers into this formula and actually do the work, because now, once this is in the graphing calculator, I'm going to hit the second button, and I'm going to hit the graph button, and it takes me to a table of values. So I have my answers for when 0 is the year. I should have 43,000 people. 0, 43,000, there it is. Year 1, I have 45,795 people. So 45,795 people. Then I go back to my calculator. These will take a few clicks that you probably won't have to do. Here we go, year 1, there's year 2. Go over, it's 48,771, which rounds up to 772. So 48,772 would be year 2. The next one, year 3. 51,941.8, which rounds up to 51,942. So go over here, 51,942. Year 4. Go down one more, there's year 4. 55,318.0, so 55,318. Let's go over here, 55,318. Not 15, there we go. There's 18. Go back to the calculator again, year 5. 58,913.7, which rounds up to 14, 58,914. Then I go to year 6. Year 6, 62,743.1, which rounds up to 62,743. 62,743. Year 7. I look at my year 7. Oh, it's not there. So I just go over one and hit the scroll down, and there's my 7, 8, 9, 10, and any other number you need to find. So there's year 7. I go over. It's 66821.4, so that's 66,821. 66,821. If I go back to my calculator, let's look for year 8. Year 8's the next one, 71,164.8, which rounds to 71,165. 71,165. 2 more to go. We go over here to year 9. Year 9, 75,791. Because it's 0.5, so that 0 will change to 1. So 75,791. And then the very last one, year 10. Year 10 is 80,717, so 80,717. And they're all typed in our table. Now, we know this problem's a growth, so it can't be this problem. That's a decay. It's going down. This is going down, so that's a decay. which is either going to be A or D. So we look at the very first value, it's 43,000. So that's about 43,000, possibly. This is closer to 40,000, so I would bet this is probably going to be my answer because that's closer to the 40,000 mark than that is. You've got a line there. So this clearly isn't going up by ones or twos or 2, 4 because we're already up to 100,000 when we get to the top there. So it's going to have to be D. So if you look at D a little bigger, you see 40,000. So that would be about 43,000 and so on and so forth. So you see the increase. These represent the years. This represents the population. So this graph has to be the correct graph. So I hit check answer, and there we go. So there's an example of a growth problem. All right. Now, let's look at another type problem. Let's see if I can find a decay problem. So, between 2005 and 2008, the average rate of inflation was about 4.6% per year. Carter Groceries is $120 in 2005. What did it cost in 2008? Well, we got a little bit more work to do in this problem. All right, so let me pull up my calculator here. Let me go get out of this. To get out of this screen, I'm going to hit second, quit. All right, so I'm going to go to my y equals, clear that out. So my problem says 2005, 2008, the average rate of inflation was 4.6% per year. Inflation means an increase in prices. So this is another this is another growth type problem because it's increase. So it's increasing 4.6% per year. $120 in 2005, that's the initial amount. So I'm going to type in 120 for 2005. I hit my parentheses. It's a gross, so this is 0.046. Move it 2 places to the left, so 0.046. I'm going to add 1 to that, so it'll be 1.046 parentheses raised to the t power. So I hit the caret button and I hit the x button. So there's my equation. And then I'm going to hit enter. I'm going to hit second graph to get to my table. There's my table of values. So notice we have 0 here. 0 represents year 2005. So 1 is 2006, 2 is 2007, 3 is 2008. So 2008 is what they're asking you to find. It's approximately $137.33. So it says round to 2 decimal places, so I'm going to type in $137.33, and let's see what happens. There we go, we got it. So you can find any answer you want to find using that, plugging it into the y equals in your graphing calculator, and then hitting second graph to look at the table.